So I wanted to summarize and come back to our chain that we talked about, our chain that we talked about in lab right before spring break, quite honestly. And that was the beer distribution system, or the beer supply chain. We talked about it a little bit in class, and then we played the beer game inside lab. And again, as we saw, for those of you who were there to play it, the beer game is simply a supply chain where we put individual students in the individual components, and then we see how the system works. So this is just an example of how we can put individual components inside a chain of components or chain of parts and see how the entire system lives or produces. So our first part of the beer supply chain was something we called the factory. And of course, usually you don't say, hey, I work at a beer factory. A factory is pretty generic. We usually say it's a distillery or a brewery. But it turns out we're going to use this word generically, factory. So here we have a system again. We have the box. It's going to take on input raw materials, and its purpose for living or existing is to produce as output beer. Okay, so I didn't label this factory up top. I labeled the process factory. What does it do? It's a factory. It does factory stuff. But again, here's our first component in our beer supply chain. It is going to take raw materials, barley and hops and the water and yeast and all that other stuff, and it's going to brew the beer, and it's going to make beer out the other side. So of course, to that we're going to add our second component of our beer distribution system, or our beer supply chain. The output, which is beer, of the factory is going to become the input of another component called the distributor, and we played this game in the lab. The distributor is also going to output and supply beer, but yet there's another component in the supply chain, and that's the wholesaler. It also takes the output of the beer from the distributor as input and then produces beer out the other side. But wait, there's one more step in the beer supply chain, and that's the retailer. So the retailer accepts beer from the wholesaler, and that the retailer now has beer inside of its process. So of course, as we've talked about, the reason why this beer supply chain was made with 4 individual components, we've been talking about resistors, V equals IR this semester, integrating things together. We know that when you put resistors, and these are pretty huge resistors, when you put resistors in series with each other, one after the other, this is 4 resistors in series, we know the overall system resistance goes way up. So if you wanted to slow the flow of beer, then you would add lots and lots of resistors in a chain to slow things down. And of course, that was the design of the federal government. We talked about this briefly after the constitutional amendment number 18, prohibition to make alcohol illegal. They realized that lasted for a while. They realized that was a really bad idea, and they had to amend the Constitution again with Constitutional Amendment number 21 to make alcohol legal again. But after making it legal, they wanted to make a system through regulations. They wanted to force a system to slow it down so that people just couldn't show up at the factory and get beer and then move on. So this system, this 4-component beer supply chain, is most definitely extremely inefficient. It has a lot of problems, especially back in the day when it was invented. It took a while for the beer to get to where it was going. So this was by design, was designed to be kind of crappy. So the retailer, that's not the ultimate end of the supply chain. The ultimate supply chain is the customer. So we've finally gotten alcohol from the raw materials out to the customer, the people, because prohibition has been rescinded, lifted, and now we're going to do it. But we're going to slow it the hell down by putting all these components inside there. So what happens is, as we all know because we played the game, the customer walks up to the retailer and passes backwards, and it flows in this direction, passes an order for beer. Bottles of beer, cases of beer, whatever. The retailer then, if they can, fills the order and gives the person their beer. And as far as the person knows, if they're not familiar with what supply chains are, they think that's sort of how beer is made. I go to the store, I buy beer, and we're done. sort of like when people, not you guys, but some folks, especially younger kids, they go to the grocery store. You know, where does food come from? Well, from the grocery store. I go to the grocery store, they have what I want, I buy it, and then we're done. And they don't really know about the distribution systems, the farmers, and the fertilizers, and all the other things in the supply chain to get it there. So this retailer could be anything. It could be a beer store or but it could be Walmart, it could be Wawa, it could be Sears, it could be any it could be Target, it could be Walgreens, CVS. Any retailer, of course, has to get resupplied. So the retailer now will eventually run out of product, which is like what we did in lab. So the retailer needs to communicate its own order back to its suppliers. And in this supply chain, there's many of them. So the retailer sends an order to the wholesaler sends an order to the distributor, and the distributor sends an order back to the factory, and then ultimately the factory sends an order back to the farmers and the suppliers of all the ingredients that make the beer and the production people. So we have a sort of a two-direction or a two-way supply chain. There's the raw materials that are turned into beer and finally get to the customer, and the customer makes their order, which eventually gets back down to the raw materials where we want to make an order again. But of course, as we saw in the simulation in lab, this can lead to some difficulties, and the problem is this order, the retailer doesn't particularly know what this order is going to be until the customer shows up. They can guess, like, hey, maybe it's 4th of July, or maybe it's maybe it's Super Bowl weekend. Maybe they sort of know or have an idea of how much they'll need. So they order from the wholesaler, and the wholesaler doesn't know what their wholesaler supplies several retailers. So that all these things are question marks. And when all of this information is question marks, then the individual components of the system have to make a guess. And of course, that can be difficult. So what happens is, as we saw inside of the simulation, if the customer drastically increases their order. Now, when I say drastic, I doubled my order. I was playing customer. I went from 4 cases a week to 8 cases a week. That's double the order. Double is pretty huge. The retailer had to say, hey, wait a minute, guessing, what if the retailer comes back in and doubles it again? I better order 16 cases. Then the wholesaler says, oh my gosh, they went from 4 to 16. That's 4 times as much. I better 4 times as much. And now they go ahead and order 128 or 64. And the whole way, and back, by the time we're done at the back of the factory, we have 500 cases perhaps. So what happens is, the uncertainty, the unknowing of what happens way at the front of the chain sort of magnifies and amplifies the whole way to the back of the chain until you get some wildly huge sort of guesses or misinformation. And of course, not of course, but it's one of the things that we always try to describe what it looks like. And business happens to call this the Bullwhip effect. So a bullwhip is something that Indiana Jones liked to carry around. It was a whip at his side. And when you snap the whip, over here, the idea is, the analogy is, when you snap the whip here, it will ripple, and by the time it ripples back to the back, it's ripping really, really large, and that's where we get this bullwhip on the backside. So it is a known effect, and people in business talk about the supply chains suffering from the bullwhip effect. And it just so happens I found a pretty good YouTube video that describes the bullwhip effect, and I wanted to take a look at it. So let's take a look at this.